Hello, my dear students. So, here is a question of the day 3, topic work power energy. And video title you can say it is like a double block spring system problem, right? So, now this question is easy only, but since it is very important for JEE advanced pattern, right? So, many questions you can see in many tests around us in which concept of this question is required, right? So that's why a very important question, right? So go through this question, then we'll discuss detailed solution. So question is very simple, straightforward, that we have two blocks, mass 2m and m. Applied forces are F and 3F with spring constant K kept on a smooth surface. And we need to find out maximum extension in the spring in this case. So question is very much straightforward, very you can say doable question also. So now give yourself at least 2 minutes and then we'll discuss this question in detail. So okay, so first why I have given this question to you. If students know the shortcut method, then it is just like you can solve this question in one step or two steps, right? So it's not like that. But why I have given this question? Because I want to introduce one more method to solve this question, right? That method is lengthy, but a very crucial method in many mechanics problems, right? So in many mechanics problems, you'll see this method, right? And see, my nature is if I get suggestion from any student, right? So then I call that method by that student's name only. Okay, that is my style, you can say. Okay. So now method 1, I'm going to solve this question by method 1. So method 1, I'm writing a King's method. Okay. So King is one student. In a juniors, seniors also one King is there. But here I'm talking about King in junior section. A very good student. Now he suggested that method. Okay. So although it's a lengthy method, little lengthy method as compared to shortcut, but it is the actual method, you can say, right? So it's a very good method. So that's why I want to solve this question by King's method. So obviously approach is what? A work energy theorem here, but with respect to any one block. So with respect to any one block, we are going to apply work energy theorem, right? And then we can find out what is required. So brainstorming angle. So brainstorming angle means we need to think that what is the condition for which extension in the spring is maximum, right? So under what condition extension in the spring is maximum, that condition we need to look, we need to think about that situation. Okay. And that condition is basically our crux point in this question, that extension in spring will be maximum when relative velocity between them becomes 0, right? So extension in the spring, or you can say compression also. Compression in the spring will be maximum, then also relative velocity has to be 0. Because as long as they are having relative velocity, it means they have tendency to extend or compress further, right? So at maximum extension, or you can say maximum compression, relative velocity between the two blocks must be 0, right? Okay, so now let's do the working part. So working part, so we are writing work energy theorem with respect to any one block. So now I'm choosing what? Block M I'm choosing, right? On block M, I'm going to apply work energy theorem with respect to 2M. So with respect to 2M means first we need to see acceleration of 2M at any instant. So acceleration of 2M at any instant, I can write F minus Kx divided by 2M, right? So Kx is spring force. So at any instant, say extension in the spring is x, then acceleration of 2m at any instant, I can write F minus Kx by 2m, and obviously towards left, because I'm writing here F minus Kx, right? So it means I'm assuming F is more than Kx. So acceleration of 2m at any instant, I can write F minus Kx by 2m. Now force is acting on m with respect to 2m. So the real forces are, the actual force is 3F, and the spring force towards left, and an imaginary force that is pseudo force. Pseudo force acting on M is ma, right? That is acting towards right, because acceleration of 2m is towards left. So this variable acceleration we are writing in a way that it is towards the left. So by that way only, pseudo force acting on m should be towards right. So that is pseudo force ma, 3f force, spring force kx, right? So now initial and final relative velocity of m with respect to 2m is 0. Initial relative velocity is given 0 only. Final relative velocity is also 0, right? So it means net work done on m with respect to 2m should be 0 beta, because change in kinetic energy with respect to 2m is 0. Initial relative velocity is 0, final relative velocity is 0. It means net work done is 0. So what are the forces acting? 3f, kx and ma. Work done by 3f force, work done by spring, work done by ma, total should be equal to 0. Okay. So now if x naught is maximum extension, so then what we are doing beta? Work done. So F is a constant force, so no problem. 3F into x naught I can write. For spring force directly also you can write work done by spring if you know the formula. Otherwise spring force is kx dx, integration from 0 to x naught. And also this pseudo force is, so acceleration we know beta, then ma. So means pseudo force will be F minus kx by 2 into dx. So integration from 0 to x naught. So total is equal to 0, right? So that I am solving beta. F by 2, this kx, integration of x squared by 2, putting the limits. So I am getting this value. So by that I am getting the right answer. X naught is equal to 14F by 3k. So that is the what beta? The maximum extension in the spring in the subsequent motion. So very important method. So method you just see beta. In this way we can apply work energy theorem on any one body with respect to other moving body. Means that is also we can do in many mechanics problems. Okay, so this technique also you should learn. Now second is method 2. I think method 2 is very common. Maybe all the students knowing this method, but okay, still let me discuss it. It is shortcut, or you can say trick. So in the center of mass frame we know that blocks perform SHM. So in center of mass frame, so it is a kind of just one block which is performing SHM, right? So equilibrium extension will be, so this force on any one block with respect to center of mass. So with respect to center of mass, Fc force divided by K. So that will be equilibrium extension, means when the block is at a mean position, at that time what is the extension, okay? And maximum extension. So maximum extension is what? 2F by K. So in the center of mass frame we are doing this, okay? So in center of mass frame if you are doing this, then this we can remember like a shortcut. So 2Fc by K. So what is Fc here? Fc is net force on any block in center of mass frame other than spring force, right? So other than spring force, it is just like one block is connected to a spring, and in center of mass frame what are the external force acting on it, and spring force is going to counter it, right? So spring force is going to oppose it, okay? So like that. So now if I'm using this shortcut, okay, so on any one block you can use this shortcut. Suppose on M you're writing, but let's write Fc for block M. So on block M what are the forces acting? So actually 3F force is acting, right? And the pseudo force. So first acceleration of center of mass I am writing beta. So acceleration of center of mass is this quantity. Net force on the system by total mass of the system. So pseudo force is M into AC. So what are the forces acting on M? This is 3F, and that is pseudo force. That's it, okay? So that is what, net is what? Fc. So Fc we are getting what? 7F by 3. So x naught is 2Fc by K, so it is 14F by 3K, right? So now the same thing we can obtain by considering Fc for block 2M also, right? So same result can be obtained if we write Fc for 2M. So on 2M what are the forces acting? The actual force is F is acting, and the pseudo force towards left 2M into AC, right? So 2M is mass of the block and AC is acceleration. So this we are getting what beta? Fc 7F by 3. So then maximum extension what we will getting? So 14F by 3K, right? So in this way we can find maximum extension in the spring. Now just related to this, one more question I discussed in the class, that was what? When you are giving some initial velocities to the block, then what can be the maximum or minimum velocity in the subsequent motion, okay? So that technique also please revise, because this system, two block springs system, that is very important model as per JE advanced trend. Okay, beta. Right. So any doubt is there, then please write in the comment box. Okay. So go through this solution. Thank you, beta.